Hello everyone, we have question number 4. In figure 6.23, the figure that you see right now is your figure 6.23. DE is parallel to AC. Okay, now what happened? DE is parallel to AC. DE parallel to AC. Okay, and DF parallel to AE. DF parallel to AE. DF parallel to AE. Prove that BF by FE equal to BE by EC. Solution. First I'll write given. I'll write in the figure DE parallel to AC and DF parallel to AE. This is the given. What we have to prove? I'll write here to prove. In to prove we have to write BF divided by FE equal to BE divided by EC. Next we have procedure. Okay, first I'll take triangle ABE. I'll write in triangle ABE. In this triangle AB, what happened? We find that DF is parallel to AE. I'll write DF is parallel to AE. This is given by the question, so we can write. Okay, so remember your Thales theorem. In a triangle, what happened? I'll write here A, B, C. Now this DE is parallel to BC, so you can write AD by DB equal to AE by EC. This is what we are going to apply in this question. Let me drag the screen a little bit. So I'll write here BF by FE. BF by FE. Then I should write here BD by DA. So let me write BD by DA. And we have to write here from Thales theorem. Okay, and I'll give here equation 1. Next I'll write here in triangle ABC. ABC. In this triangle ABC, what happened? DE is parallel to AC. DE is parallel to AC. So what happened? Let us use the Thales theorem here. So I can write here, just see here, BE divided by EC. BE divided by EC. BD by DA. BD by DA. Okay, here the same reason. I'll write from Thales theorem. And I'll give here equation 2. Okay, so when we see equation 1 and 2, what happened? Their right hand sides are equal. Even in the first equation we have BD by DA on the right side. Even in the second equation we have BD by DA. That means for these two equations, what happened? The right sides are equal. Therefore, even their left hand sides will be equal. So let me write here from 1 and 2. We get, what we get here? We get BF by FE equal to what? BE by EC. This is what we have to prove. So the proof is done. So we'll write hence proof. We have question number 5. In figure 6.24, the given figure is 6.24. DE is parallel to OQ. DE is parallel to OQ, and DF is parallel to OR, so that EF is parallel to QR. Solution. First I'll write given. I'll write here in figure DE is parallel to OQ and DF is parallel to OR. This is the given. Next we need to write to proof. To proof. We need to prove that EF is parallel to QR. Next we need to write procedure. I'll continue here. In triangle P O Q, or you can say P Q O, that is up to you. What happened in this triangle? In this triangle what happened? DE is parallel to OQ. I will write DE is parallel to OQ. Okay, since DE is parallel to OQ, we can write here PE by EQ equal to, I can write PD by DO. This is what I can write. And here I'll give equation 1. For what reason I can write? This is all because of your Thales theorem. So I can write from Thales theorem. Next we'll consider triangle POR. I will write in triangle POR. In this triangle POR what happened? I can write DF is parallel to OR. I can write DF is parallel to OR. I'll show you now. DF is parallel to OR. This is given by the question. So what happened? We can write like before. I can write here PF by FR equal to, I can write PD divided by DO, and here I'll give equation 2. The same reason we'll give here also. We can write from Thales theorem. So when we see equation 1 and 2, what happened? Their right hand sides are equal. Even in the first equation we have PD by DO. Even in the second equation we have PD by DO on the right sides. Therefore their left hand side will be definitely equal. From 1 and 2 we get, I can write here PE by EQ equal to PF by FR. Okay, I'll draw this triangle PQR. This is PQR, and I'll take this E here, and this is F. Let me join them. So what you get here is PE by EQ. PE by EQ equal to PF by FR. What does it mean? It means that this EF is parallel to QR. So how we're going to give the reason here? From the converse of Thales theorem. What I can write? I can write EF is parallel to QR. Hence, proof. We have question number 6. In figure 6.25, this is figure 6.25 that we see here. A, B and C are points on OP, OQ and OR respectively. We have here 3 points. The points are A, B and C. These points lie on the sides OP, OQ and OR respectively. That means the first point A lies on OP, the second point B lies on OQ and the third point C lies on OR, such that AB is parallel to PQ. AB is parallel to PQ and AC is parallel to PR, so that BC is parallel to QR. We'll start a solution now. I'll start solution here. Okay, first write given. In figure, I can write A, B and C are points on OP, OQ and OR respectively, such that AB is parallel to PQ and AC is parallel to PR. Next we need to write to proof. What do you have to prove? We have to prove that BC is parallel to QR. I'll continue here. I'll write procedure and I'll drag the screen. First I'll write in triangle POQ. In triangle POQ, we know that AB is parallel to PQ. AB is parallel to PQ. And then I can write like this: PA by AO equal to QB divided by BO. This is all because of Thales theorem. So let me write from Thales theorem. Okay, let me show you properly. I'll draw this OPQ here once. This is OPQ. AB is what? Parallel to PQ. So I can write this PA divided by AO will be equal to what? QB divided by BO. Next, I'm gonna take triangle POR. So let me write here. In triangle POR, we can write AC is parallel to PR. This is given by the question, like this one. So I can write here PA by AO equal to, see properly here, PA by AO, then you can write RC or CR. RC by CO. This is what you can write. So this is all because of the Thales theorem. So I'll write here from Thales theorem. Okay, and here I'll give equation 2. What happened here? In both equations, equation 1 and 2, we find that their left hand sides are equal. That means even their right hand sides should be equal. So I'll write here from 1 and 2, we get, what we get here? We get QB by BO equal to RC by CO. This is what we get now. Okay, let us observe this carefully here. Let me draw here triangle OQR. OQR. I have drawn now. Here we have B and here we have C. QB, divided by BO equal to what? RC divided by CO. That means I can conclude that BC is parallel to QR because of the converse of Thales theorem. So let me write here, from the converse of Thales theorem, what we can conclude? We can conclude that this BC is parallel to QR. I can write BC is parallel to what? QR. Hence, proof.